Hello and welcome back to this vocabulary. Two. Alright, so first our topic is polygons. And basic geometric concepts. First word, polygon. So this word has two parts. It's like the word Polynesia, which is a area of the Pacific with lots of islands. So poly means many, and nesia is Greek for island. Or polyglot. A polyglot is someone who speaks a lot of languages. Glot being named after the glottis in the throat where you speak from. So someone who has many speaks. There's even a word called polymath, like Neil deGrasse Tyson, or other famous people who know a lot of science and mathematics. And even polyethylene. Polyethylene. This is an ingredient in plastic, and basically it means many ethylenes. Ethylene is like methane, but when you link them together in these long chemical chains, they become polyethylene because there's a lot of them, many. So, what does polygon mean? It means many gons, of course. Just kidding. Gon is Greek for angle. So many angle. Although you can just have three. I mean, a triangle is a polygon. What is its definition? It is a geometric shape made with straight lines on the plane. On the plane means that it's flat. It's not 3D, it's 2D. So it's 2D. And geometric shape made with straight lines on the plane containing angles. So it's made with straight lines and angles. And I forgot one word, closed, which means it meets back up with itself. You can put this anywhere, back up. It's not an open shape. It's a closed geometric shape made with straight lines on the plane containing angles. Let's do some sketches. So as long as these are straight, and as long as, here's a nice pentagon, a funny looking pentagon. Nice. Square is a polygon. I already drew a triangle. I mean, they can be concave too. That's a polygon. Okay. A regular polygon is a polygon with all sides the same length, all angles, this is our symbol for angle, so none of, well, this square, if this is a square, this is a regular polygon up here, draw another square. Squares have all the same length, so those little marks mean these are all the same, anything with one, and all the 90s, so it counts as a regular polygon. Let's see if I can do a regular pentagon. Not looking good. I think that angle's wrong. Come on, widen it out a little. You know what? I can force it to be a regular polygon by adding these. Aha! Now, conceptually, those are all the same angles, and I'm going to give all these a double. Not a lot of room, huh? I give those a double mark because this they're not the same as the square. They could be. I guess I could have single marked them. What else can we do? Okay, we can do a triangle. Equilateral triangle is a type of regular polygon. And of course, everyone's favorite, the hexagon. Oh, not looking very regular. That's okay. I can force it to be regular. I'll give it. I'll just use 1 again. Even though, pretend this is a different diagram. And then I'll use the funny arc with the mark to say all these are the same. There we go. Okay, turning now to the concept of bisector. Or bisect. Bisect is the verb. To divide into 2 equal parts. Bisector, a feature that bisects another feature. So if we have this segment and we want to bisect it with, let's say, just a diagonal line. Ooh, that was not very close to the middle, but let's just add some marks and now voila, it is bisecting. Okay. We're going to stay on this topic with the perpendicular bisector. Which is a line segment that bisects another line segment at right angles. So now this line is bisecting this line segment. This ray is perpendicularly bisecting. Okay, so we have bisectors and perpendicular bisectors. And right now this line is straight, but what if it was kinked? What if it had an angle? And what if you still wanted to divide it in half? But now it's the arc of the angle that you want to divide up. So, oh wow. That was a dramatic fail. Okay, so right now this line is flat, but let's say it was kinked. It was making an angle, and you wanted to divide it in half. Let me erase this really quick. And you wanted to divide this in half, but now you want to divide it, the angle arc. So that this angle and this angle are the same. Now I have to put these little marks at different heights so you can tell they're different, but the fact that they're 1 and 1 means those two are the same measurement. Maybe they're 20 degrees, maybe they're 30 degrees, I don't know. Conceptually, I'm just saying they're the same. And if they're the same, this angle is now bisected. So this is an angle bisector. Angle bisector is a ray that divides an angle into 2 equal smaller angles. And lastly, hopefully no dramatic fail this time, we will do diagonal. A diagonal. Which is a line segment that connects two corners, which are called vertices. A vertex is just a corner. A line segment that connects two corners of a polygon that aren't on the same edge. So if we had this guy, not a regular pentagon, just some sort of sloppy pentagon, but it has some diagonals. Here's a diagonal. Those corners are being connected. They're not on the same edge, though. They weren't already connected by an edge. So here's another diagonal. This thing has a diagonal. This is a diagonal. And I'm missing one. Oh, yeah, this one. I think I messed that one up. Okay, but anyway, you get the point. There's a bunch of diagonals in there. Square is a little bit more, or even a rectangle. There's just two. Dun, 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 dun. Of course, a triangle has none, because all the corners are already connected. Let me see if I can do a hexagon. Man, my hexagon's really... I'm sure this is very thrilling content. What? This one's missing one. This one? Yeah, there we go. A hexagon and all its diagonals. All right. Thank you for watching to the end. Consider liking.